testing, testing. I'm testing for online. Let me know if you can hear me. Testing, I'm testing. Testing, can you hear me? Can you hear me? I'm testing for online. Let me know if you can hear me. Testing, 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 testing. Can you hear me? Can you hear me? I'm testing for online. Let me know if you can hear me. I'm testing. Let me have a look. Okay, can hear me perfect. Great. Just go from here. Okay. Great, thank you. Let's get started. All right. Hello, everyone. Welcome to week 3. How's your part 2 going? You got started? Yeah. Hands up if you have started part 2. Great. Yeah, almost all of them have started. Perfect. Get started. So that's the key point here. We really need to get started on part 2. It's not that hard. It's just the workload is like more than the part 1, which is pretty obvious. So because you need to write tests, you need to write functions, but they are not very hard. But you need to plan ahead, get started, do the stand-ups, have the issue board, so the meetings. Yeah, you need to get started. All right, so today we'll talk a little bit more about part 2, and then we'll move on to talk something new. So last lecture, until the lecture from last week, we have already finished all the concept that is required for your part 2. So you are not learning anything new for your part 2. And we also walked through the project spec, so briefly for the part 2. So today I'm just talking a little bit more on part 2 and also showing you more examples. So there's also another very helpful resource for you that I've emailed on Monday, so on the week 3 newsletter. So there's a link to a video demo created by our tutor Mandy. So they provided some very useful examples showing you how to write tests. So I strongly recommend you to have a look at that video, especially if your tutorial is at a later date in the week. So for example, if you have a Friday tutorial, do not wait for it, get started, right? So have a look at that video. It shows some very helpful examples. It's helpful not only for the project part 2, but it's also helpful for your week 3 lab. So there are some practical examples there. All right, so let's have another look at the project spec. Before I start, do you have any questions about part 2? So we can start from questions, if you have any. Oh, good. Okay. Yeah, cool. Yeah, if you have any questions, you do not need to wait for the lectures. You can always ask on the forum. Our tutors are there every day. Cool. So we have went through this already. We have went through this from last lecture. Yeah, just have a look at the, where is it? Not that one, not that one, not that one. Where's it? Where is it? Huh. Lecture test one. Yeah, here. Here is it. All right, so this was of a data store. So you can modify this object below here. So you can object the data that you want to store in this project. So you may want to have, for example, the user information, right? So user information, the user data is quite important for like a Tahoe project. Other kind of data, so what other kind of data do you think is also important for this project? You also want to store in the data. Yeah, at the back? Yeah, exactly. Yeah, you also want to store the quiz data there. But for now, especially for iteration 1, we just started, you do not need to overthink about it. Just user and quiz. So that will be enough. So more details will come in later, and you can always add more like data structure to this data. We also got a very good question from the forum, like why is it this data declared using let rather than const? Because when we mention like we always recommend using const, right? So when we declare a new object or a new array, like why is it declared as let here? So you can change that to const. You can also use let. You can change it here, but you need to be mindful because if you declare the data here as const, it means that you can't assign another object to this data variable. Remember that when we say like when we declare an object or an array using const, we can change the value in that array or in that object, but we can't assign a new object to data in the future if you declare that as const. So why do I mention about this? So why do I mention like we can't assign another object to data? Remember that in the project, there's a very, very important function called clear, where you are going to clear all the data, right? So I'm not going to give too much answers, but you need to consider that. So if you are assigning another, like for example, empty object to this data again, when you are using that clear function, like it's your design decision, but if you are doing that, you need to declare as let. So you can't change this data to const if you are assigning an empty object to data in the future, especially when you are doing the clear function. So that's one consideration here. So now below we are giving a function here called getData. We also give you some examples like how you can use this getData. You can also define your other functions here that are about data. So any other functions about data, you can put that in this data store.js file. So this file is about data. So that's this part. We also got some very good questions on the forum about like how do we structure the files, especially the test files. Like how do we structure that? There are 2 dimensions for that. So part of this question is how do you structure the files, like the test files? Right. And the other part is like how do you have the test for the functions in terms of branches? I'll talk through them one by one. So for the test, so for example, we gave the example for, oh, is it too small? I'll make it a little bit bigger. So for equal, so this is an example here. We give you an example like this function called equal, and how do we test for this equal? Right, so you can see that there's only one function here on this equal.js file. So we use another test file for this function. So this is one option. So you can have one test file for one function. So you have the admin auth register. Right, so this is a function. So that function sits in your auth.js file. Right, so, but in this auth.js file, you have multiple functions like admin register, admin register. Sorry, what was the function's name? It was admin auth register, right? So in that file, you also have admin register login. You can have one test file for multiple functions. So you can have one test file called like auth.test.js. And in that test file, you can have like a test for admin auth login, admin auth register. It's just design option. However, you may notice that like you have a really big file like later because you have a lot of functions for auth. Right? If you have a test file for all the AEST functions, the file will grow very large. So you have two options here. So our recommendation is you can have one test file for one function. So you can have a test file called admin AEST login.test.js, and then admin AEST register.test.js. Right? But this is just recommendation. You can also have two tests for two functions in one file. Right? It depends. It's just your design decision. Right? But you can start with one test file, one function. So that's easier. It's also easier to read from like the file name, so they know, well, this file is for test for that function. It's pretty clear. Yeah, so that's about the structure of the files. Another question that was very commonly asked was like, how do we structure the test files on branches? Because from part one, remember that you have one branch, one function, right? But for now, we are also having tests. So you can have one separate branch for test, is okay, but you can also have one branch for the function and the test for that function. So you may have a branch for admin AEST register, and on that branch you have like the function that you define for like admin AEST register, but you also have the test for this function. So it's also pretty clear when you check out a new branch, like have a new branch, you can name that branch as, for example, iteration 1, part 2, and then admin AEST register. And on that branch are the changes, are the features about this register, including both the function implementation and also the test. So it's also pretty clear. Again, this is just recommendation. You can make your own design decision. Yeah, so let me have a look at what are the other commonly asked questions. Another commonly asked question is, what does black box testing mean? Any thoughts from the audience? So what's your understanding of black box testing? Yeah.
It's basically like maybe when you write tests without knowing or without considering how the function is implemented, so not for any specific implementation, but the test should like pass for any correct implementation.
Yes. So just to repeat your answer, it means that when you write the test, it's okay that you don't know how it was implemented, how it will be implemented, right? So it doesn't matter how you implement that function. The input and output should be just like that. Right? So we also have the example here for the eco.test.js. So you can see that you can ignore what is implemented here. So all you need to know is what this eco function does. Similar for AEST register, right? For the register function, you don't need to know how you implement the register function, like how you implement the body of the register function, but you can write the test. So that's what we mean by black box testing. So in the future, you may want to refactor the register function. You think, oh, this function is not right, although it's correct, but it's not right in a very elegant way. So you can change the body of the register function, but that should not have impact or influence on the test. So the test should always pass. Yeah, so that's the question about black box testing. So if you found that when you are writing your test, you are referring to the implementation details of that function, it means that you are not writing black box testing. Does that make sense? Yeah, so when you are writing the test, if you find yourself referring to the implementation details of the original function, it means that you are not doing black box testing, because black box testing should be able to be done before you actually write the details, like how you implement that function. Yeah, any questions so far? Yeah, question.
What do you mean with black box testing, you find an error before the implementation?
Sorry, can you repeat your question?
What do you mean by when you say black box testing, you like find the problem before the implementation?
Find the problem before the implement. So when you write black box testing, like when you write the test, you are just testing the expected output with the function's like output, right? So it's just comparing the output, like the expected behavior of the function. So you are not referring to the implementation details of that function.
What does implementation details?
Implementation details means anything here. So you only have like input, output. You haven't implemented anything about this function, like the body of this function. And then you can start with the start function. Yeah, the start function. Make sense? Yeah, any other question? Cool, so what are the other commonly? Oh, yes. Another question was about the clear function. If you have read the spec, you may notice that there's a function called clear. What it does is it resets the state of the application back to the start. So why is it important for testing? Like, why do we need to have a clear function for every test that we write? Yeah, the back.
Because it allows you to test multiple tests in a row instead of having to restate your program each time, so that you can clear all the data and then set up correct data for the next test.
Just to repeat the question here, it means to clear the state of the application before the test, make sure that you can have multiple tests in one test. Like why? But why? Or like why is it?
It's much better to test lots of test cases. You can do all your test cases in one go and just write it up nicely.
Yeah, but more than that. So more fundamentally, like why do we need to clear the state of the application for our test? So remembering that we have the data, right? So we have the data for the users and also the data for the quizzes. And while you are doing the testing, for example, you have already tested like the behavior, some of the behavior for register. So for testing, you need to assign some values to the user so you can test, right? But then the values may have influences for the other test. So you want to clear to the original state so that you can do another test. You don't want the test to have some overlaps and so one test is impacting the behavior of another test. So this is what you do not want. So this is why before all the tests, we need to clear the state of the application. Does that make sense? Yeah. Feel free to raise your hand if you are confused or you want further explanation, and I can explain more. So that is the clear. Clear function is also very important. As we mentioned, you want to clear for all the tests. So make sure that you write that clear function first, because all the other functions are depending on this clear function. Question?
Like you reset this app, like what do you mean reset the application to start? Wouldn't the application just restart when you close the application?
Oh, that's a very good question. So I just repeat the question. So what do we mean by reset the state of the application? Does it mean when we restart the application, the state will be cleared, right? So that is what we call by persistence in software engineering. It means that when we restart the application, everything is back to the original state, like empty. So yes, but when we are testing in one file, we are not actually restarting the application yet. So we need to manually restart by using clear.
Oh, like in a test.
Yeah, in a test.
One test and then you clear the next.
Exactly.
Okay.
Yeah. Question?
I want to ask for the iteration one, part one.
For part one?
Part two.
Part two.
Is it enough, just to delete everything in the data? Is it enough for the clear?
The question is for part two, is it enough to just clear all the data in the data?
Yeah.
Yes, that's enough. Yeah, the clear function shouldn't be too big, should be very, very brief. Yeah, any other questions so far before we move on? Yeah, question?
Is there an order in which we have to
So the order for the implementation of the functions?
for the test? Is there an order we have to make the test in?
Is there an order to write the test? like there should be an order. So for example, you may want to write the test for clear function first because you need to have clear function first. The other functions that you may want to prioritize are the admin auth register and admin auth login. So these are another two functions that you may want to prioritize. Because if you draw the dependency graph, you will notice that these three functions are the functions that are the dependencies for other functions. So make sure that you implement those three functions first before you move on to write other functions. And also the functions here, so all these functions here, some of functions are easier, some functions are like a little bit like more challenging than the others. The easier one are the ones with an update. So the update, so for example, I mean user password update, so this one, all the update functions are relatively easier functions. So you may keep that in mind, like where you assign tasks to the group members. Cool. I strongly encourage everyone to practicing doing the dependency graph because for this iteration, we told you, well, you need to write clear first and the other two functions first. But for the following iterations, we encourage you to do that yourself, like make your decisions. Sorry? Like make decisions on which function to write first and then which function to write next. Yeah, the priorities. Yeah, let me go back to my notes here. Yeah, I think we already mentioned there's also a question about like the clear function, admin auth register and admin auth login. So actually those functions are kind of depend on each other to test. For example, to test a clear function, you may want to call like admin auth register or admin auth login, all right? So when you find that, so you have some circular dependencies, like one function depends on the other one also depends on another one. Like how do we solve this problem? The solution here is that you can assume one of the function has been implemented correctly and then implement the other function, like the test and that function. And then you can go back to the other one. You can assume one function has already been implemented correctly and just do the test and write the function for one of the function and then go back to the other. So that's what we normally do when we have like circular dependencies. Yeah, question?
So when we go back to change the test for the other one, should we then make a new branch off master for that again?
You can reuse the original branch. Yeah, you do not need to create a new branch for that. Yeah, we also covered this one. Yeah, so this is one suggestion, one hint here. So when you have like the dependencies, so the circular dependencies, right? You are assuming the other function is implemented correctly, but it actually hasn't. So the the test will fail because that function hasn't been implemented. So what you can do is you can use this function called test.failing. You can do a little bit more research on that yourself, homework. So you can use this function. So there is a function here available for you when you have those kind of circular dependencies. Right? So in total, there are 12 functions. Yeah. And the function is split between auth.js and quiz.js. So some other functions are about auth, some other functions are about quiz, but we also have other like JS functions. Like when you assign tasks, we recommend that you do some functions in auth and some functions in quiz. This is to support you for future iterations. So for example, if you are only doing auth functions for iteration 1, then you may have no idea like what are the quiz functions. So in the future iterations, it requires you to have more knowledge about like the other parts of the project. So my recommendation here is to do some functions, so for all group members, do some functions in the auth.js, like auth functions, but also do some functions from the quiz functions. So that will help you build a solid foundation for the future iterations. Yeah, so one more thing is about the error. So you may notice from the eco.js file that we gave you, in addition to just input value and return value, there's also one here. So we want to have, like, if there's an error, like unexpected behavior, like how do we deal with this error? The way that we do now, for now, is just return like an object. So what we are returning here is an object. So in this object, there are two key value pairs. The first one is the key is error. The value is like the error code. And this is the second key value pairs. So why is it important? Like when we write functions, why don't we just have like given input value, we return value, right? So why do we also need to consider errors when we are writing functions? Any thoughts from the audience? Like why do we need to write error cases in the functions? We can figure out whether there's an error or not? Yeah, any other thoughts? Yeah. So the user knows what they need to change in their inputs. Yeah, so both are correct. So you all have experienced like a software product returns you with an error message, right? So when you try to log into a website and your password is wrong, and then you saw an error message saying that your password is incorrect, or when your email hasn't been registered on that platform. So you all have experienced that. So this is very important. Imagine that you are using a website, you're trying to log in. It just say error without telling you, like, is it password wrong or is it because you haven't registered for this platform? That will be very confusing. Right? So this is why it is important when we design a software product, we need to return an error message, letting the user know what is wrong. So this is not only important for the users who are using the software, but also important for like software developers or other people on the team. So when something goes wrong, they know what is wrong. It needs to give us an error message so we know how we can solve that problem. Right. So now for iteration 1, we are doing like the error like pretty naive, so I can say naive, because it's not very elegant. We're just returning an object with like, for example, error type and then the message. But in the future iteration, we'll also learn like how we can deal with the errors more elegantly, like more aligned with industry practice. But for now, we're just doing it like by returning an object. Any question about the error so far? Oh, good. So how do we implement the error? So you can just return this one, something like that. Very similar, like how do you, very similar how you implement the error return for other other functions. You just return this error object with the message. So the message you can define your own. So you can just explain what your understanding of this error is. So it's not marked, it's just a practice. Cool, so when testing, do we also need to test error cases as well? Yes, we also need to test those error cases when we write the test, because we not only want to make sure, well, the happy paths work properly, like the happy paths are like doing what we expected, but we also want to make sure that the errors are also returned properly. So for example, when you try to log in a system, right, you put in the incorrect password, but the error message returned to you is you haven't registered for that platform. That'll be really confusing, right? So we also need to make sure that we have tests for those error cases as well. Yeah, cool. So next, yeah, so I'm going to give some hints on some of the functions and also some of the tests. So I'm using this main auth login as an example. So I'm not saying that this is the perfect, this is the complete version, but it can give you some hints. So this is how we can start with implementing the admin auth login function. So you need to export that function so that you can import that function when you write the test. Right? When you depend on this function, you are calling a min aus login in another file, right? You need to import that later. So you need to make sure that you have export here. And then because you may want to use some like functions about the data. Well, the functions about data are from another file, so you may also need to import those functions from other files. So this is about import and export. So the modify in JavaScript. This is how we can write the error cases. For example, the first one, right? So if we cannot find this person in our data, like the user data, so we assume, well, this user hasn't registered, right? So we can return an error message, well, email not found. All right. So all the user has found, so we have found the user's email. However, its password is different from what we stored in our data. So we say, well, there's another error saying that there's incorrect password. However, if everything works well, we just say, well, you can log in. So this is how we can write the min login function. So then we can move on to write the test for this function. Oh, sorry, I made a wrong order. What was wrong here? What did I do wrong? I should write the test first before I actually write the function. Yeah, good pick. Yeah, so here's my test file for aus login. So you need to make sure that you import the relevant function from the other file so you can test them. Before each, so we also put this hint in the spec. So I'll show you here. So before each is a jest function. So when we install the jest from using npm, there's a function that we can use directly, which is called before each. What it does is it runs the function before each of the tests in the file runs. So what we wanted to do here for now is just we want to clear first before we run all the tests. So that's the only thing that we want to do now, but in the future you may want to add more. Okay, and then you can start writing your test. So the test cases that I have here include, well, we want to test unregistered user, we want to test registered but incorrect password, but we also want to test a successful login. So you can see that I not only tested the happy pass, but I also tested the error cases. Yeah, just a very brief example. The implementation detail is up to you. I'm not saying this is perfect, not correct, maybe also not complete, but this is an example that you can use to get started. There's a question online. Will we lose marks if not all members are doing at least one OS and at least one quiz? No, you will not lose mark for that. It's just a recommendation. It just helps you to build foundations for future iterations, but it's not required. There's also another question from Angela. What will we return if multiple error types occur? Wow, that's a very good question. So we will explain that. We will do that for future iterations. But for now, just one error case, return one error for one case. That will be enough. We will talk more about that in the future for future iterations. Great. So this is question. Why do we need to import? Oh, so this is my implementation. So I had all the error in error type file, so like a helper function. But it's up to you. So it depends on how you design your implementation. Yeah. Any question before we move on talking about something new, more exciting? Yeah. Question. The question is for the test, should we put it on a master branch or on a separate branch? All features, including the functions like the feature and its test, it should be on feature branch. Yeah. Question.
Oh yeah. Since this is the 1.2, do we make a new branch for 1.2, or should we continue with the branch we already made for like admin of login?
Yeah, that's a good question. Because in part 1, you already had a branch, for example, admin auth login. Like, should you make another new branch called it like part 2 and then again, it's up to you, but my recommendation is make a new branch for that. So it's pretty clear, like what you have done for part 1, what you are doing for part 2. It's more clear. But
On branches, can't you like go back to old iterations or no?
what do you mean by go back? Like go back to previous commits?
Yeah.
We don't recommend doing that.
Oh, okay.
Yeah, it'll be very confusing in the future.
Okay.
Yeah. All right. Any question about the project? Otherwise, we are going to talk something new. All good. All good. All good. All good. Okay, cool. So this is all about the part 2. Yeah, we are going to talk about something exciting. I'll just close that. Yeah, continuous integration. Do you remember in the very first week, we talked about like software engineering solve the problem that a single developer cannot do. For example, a single developer can make a software product, no problem. They can do an application that do some like, for example, to-do list or messaging app or whatever. But one single developer may have challenges when the project grow in scale, like the scale of the project and also the scale of the team. Right, so for now, we have learned multiple strategies like how we can address this by using Git, by using jest test, or by using like NPM libraries, right? But there are some other like approaches that we can use to help us when the project goes in scale, and also when the project is designed and developed for the real users to use. Okay, so this lecture will talk about like when we want to scale with a multi-user software projects, like how we can automate and integrate the test code, like how we can do that. So for now, the way like we do tests is by using NPM run test. It's great, right? We do not need to manually compare the expected output with the actual output, like by using console log, console log, console log, right? It already solves a lot of problems. But we want to make the process even better. Right? So for example, when you are approving your team members' code, like for merge requests, you like approve, like whether my team members can merge their branch in the main. You may still need to manually do NPM run test to make sure like their functions work well, pass at least their own test. Right? So you still need to do some manual work. But today we are going to talk about like how we can automate this process. For example, when you are reviewing another people's work, when they want to make a merge request, it would be great if GitLab can show us like whether their functions pass their own test or other people's test. That would be amazing. Right? So you can know like if they're saying, well, their functions failed the test, you know, well, I can't merge that in. So we can't merge that into main. So it's unsafe. Right? So this is what we are going to introduce today. So it is called continuous integration. Continuous integration is broader and more than what I just mentioned. It's a practice of automating the integration of code changes from multiple contributors into a single software project. Like it helps us with merging things in when we are working with multiple people. So it helps make merges into master more frequent and stable. Right? Because the process is easier. It's less manual work, so we can do it more frequently. Right? And it also shows us whether the test pass or fail, so it's more stable as well. Yeah, so what it actually does is automatically run NPM run tests on all commits. So when you are pushing a commit to the remote repo, we run the test. When you push a new commit, so you are like make changes to another function, it runs the test for you. So all the time it shows you what works, what didn't work. It will be great, right? And it also gives you a visual, okay or not okay summary on GitLab. That will be fantastic, right? But how can we do that? I'll show you. So every Git website has its own way of handling this continuous integration. But like the logic, the concept underneath is the same. But we are just using GitLab for this course. But after you understand the logic, the concept, you can easily move on to another platform. So on GitLab, what we do is we add a new file called .gitlab-ci.yaml file. So this is the name of the file. So GitLab will automatically know, well, this is the file that I need to read for like setting up the continuous integration, like giving us the OK or not OK sign, right? Like automate the process. So it's like the .gitignore. So when we name a file as .gitignore, so GitLab or Git knows, well, those files in this file, in this .gitignore is like I need to ignore for any Git. Similarly, this is, you need to name it that way so that GitLab knows, well, this is for the continuous integration. All right, I'll show you how to do that. Let's continue using of a project that we used before, which is this tester project. Let's continue using this project. So what time is it? Okay, cool. So this is our project, so our tester project that we created together in the previous lectures. I have copied those two files into this folder, which is the jest.js file and the test files. So these are the two files that we wrote together in last week as well, so I put them here. So what I also did is I also updated the package.json file and package-log.json file. So there are a few like setups that we need to do. You do not need to worry about that. You will find those package.json file, package.log.json file from your labs or your major project in the future iterations. Yeah, so all we need to do now is, since we've already got the package.json file, we can do npm install, so we know we are installing all the dependencies. All right, cool. So now we can move on to add the file that we just mentioned, which is called, I'll just copy it here. Where is it? Yep, this file. I want to add this file. Huh? Where is it? I have too many files open here. So I'll create a new file and put its name here. All right, perfect. So this is the initial process for us to set up this continuous integration. It's by adding this file. So we also have a template here. Sorry, so many files I'm navigating through. Where is it again? Oh, it's here. Great, so just copy it here and I'll explain what they are. I won't have those. All right, so this is of it's called a YAML file. You can see that it's called .gitlab-ci. So CI represents for continuous integration, and it's a .yaml file. So .yaml file is very similar as .json file. So it's a type of file that like we store some data in that. So again, it's not runnable. So there's no script like JavaScript or C. You cannot run the file. So everything in this file is like some data you store there. It's like your .json file, so similarly. Right, so you can see, what is it here? So in this file, we are telling them, so image is, we don't cover much about Docker in this course, but you just imagine like this is the environment. So this is the environment that we are going to run for this continuous integration. And we also have multiple stages for the test, like for the continuous. So there are multiple stages that we want to automate here. And here's the test that we want to have. So we are not actually having real tests. We are just equal hello. So it's like print out this hello message. I feel like you are tired. How can I cheer you up? Shall we have a quick break for maybe 5 minutes? We are having this break earlier today because I can see that you are tired. And then we can come back. Yeah. All right, have a break. We have an earlier break today. should our package.json file after npm install should only have just welcome back. Welcome back. Hello. Oh, it's working. Okay, great. We had a pretty long break this time because we got a few good questions during the break. So that's why it's a little bit longer than expected, but it's okay. We have a question online from Hossein. Should our package.json file after npm installing jest should only have jest as the only dependencies if that's the only thing that we npm install? Yes. So the question is about the package.json file. So dependency. So we have shown that like the dependencies here before. If like whatever here sits on the dependencies are the dependencies that you install. If you don't install it, it will not be there. But another way to think about it, like when we are working on top of other people's project or collaborate on the same project, we need to sync this package.json file. Means that everyone on this project has the same package.json file. And how do you make sure that you have all the dependencies for that project? It's by using npm install followed by nothing. What it does is npm install followed by nothing. It will install all the dependencies in the package.json file. So this is also how we do how we release the project for future iterations. You don't need to worry about that for now, but when we release iteration 2, how do we make sure that you have all the dependencies for your project? It's by like we release the updated package.json file. So we give you the package.json file and the package-log.json file. So you will know what are the dependencies that you will need. And all you need to do is by just using npm install, and you will install all the dependencies that we give you for the major project. Does that make sense? But if you start from a scratch project yourself and you are using like npm install jest, npm install blah, 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 and then the dependencies will only be the ones that you installed. Yeah, I hope that clarifies your question. Okay, so let's come back to this gitlab-ci.yaml file. So this is where we define the continuous integrity, like what we want to automate. Right? What about I come back to this file? I'll just show you how it automates the process, and then I'll come back and explain like what each line means, so you have an idea like what we are doing. Okay, so I have at this gitlab-ci YAML file, and then I was hoping to have, okay, I'll demo first and then I'll come back to how it works. Okay, so now the first step is at that one. Yeah, so GitLab, so Git is automate the process for us, right? So we need to push these changes to GitLab, because otherwise, if we don't push the changes to GitLab, GitLab will not know what we have changed, and GitLab cannot help us to automate anything. Does that make sense? So we need to first push all of the changes to GitLab. So GitLab knows, well, oh, you added this gitlab-lab-yaml file, right? They know we have made the changes. So let's push the project changes. Am I on the? Yes, okay, cool. Git add -- I'll just git status first as a good habit, and then git add -- I'm adding all of them together, and I'm having a commit message, so just say my commit message is set up for continuous integration, Okay, then, yeah, and then I'll just git push. Let's have a look on our remote repo on GitLab. So what I'm going to do here, you can see here, so after we commit this, push this message, there's a new icon here. Let's click on that. It says it's running. Oh, it's passed now. It means the test or the script that we set up in that YAML file passed. Let's click on it and see what's in there. Does that look very familiar to you? Have you seen something similar before? Yes, where did you see it? Have you seen something like that before? Yes? No? Hands up if you have seen something similar. Yeah, where did you see it? Automarks. Yes, that's the lab automark. So our lab automark is actually using this YAML file, using this continuous integration to test your work, to test your project. All right? So we are actually using this continuous integration already. So you are not like, it's not something new to you. But you can see that what they are doing now, they are preparing for the Docker. So Docker is like the environment information for running all the tests. They're preparing for it, and then getting the source from Git repository, like our repository. And then all we'll do is just echo hello, so console log hello here. So why is like that? Because the script that we give this continuous integration is Adam to echo hello. So this is like, you can see that the process is automated. So we pushed a new update to GitLab, and then they are running it. They are running this script for us. So it means like when you are making some changes to your project later, when you push that to GitLab, it will start running the script. So this is an automated process. But how can we automate the test process? So this is what we wanted, right? So what we wanted was, when I made some changes to my project, I wanted to automate test, whether it like passed the test or failed the test. So this is what we wanted. So how can we do that? So all we need is just to change the script here. So we can add another one. So we can say npm run test. So we can update the script here. So this is the script that we want this continuous integration to, which we call pipeline. So this is called pipeline. So the process, so the script here is called pipeline. So we want this pipeline to do this continuous integration for us. So we are updating this pipeline, and then let's try to push that again and see what happens. Just go back here, test the project. You can see there's a green tick because everything in the script passed. But let's make some changes. I add npm run test here, and then git add. So I just git status first, and then git add --r, git commit -m, add just test to pipeline. All right, so I'm going to push it to the remote repo now. Before I do that, I'll open this remote repo, and then I'll show you. All right, I'm going to push now. Look at here, look at here. I'll hit return, enter the password. All right. You can see that it's running again. So this icon is running again. So I'm pushing a new change to GitLab remote repo, and now they are running the script that we set up in the YAML file. So let's click on it. Oh, it's already done. It passed, everything passed. You can see that there are two scripts that we added in the YAML file. One is echo hello, just console log, like print hello. The other one is our just test, and it passed. Magic, right? So with this continuous integration or this pipeline, every time we pushed some changes to the remote repo, GitLab will run the script for us automatically. So we can see that on this project, there's a green tick for us. All right. Any questions so far before we talk a little bit more about that? Any question online? No. Yeah, question.
So let's say we're like reviewing a merge request and we want to use this. So we go into that feature branch and then we can see that?
That's a very good question. Like how we can use this feature when we are reviewing merge requests. That was the question that we had at the beginning of the lecture. All right, that's a very good question. We'll come back to that. We'll come back to that. But before we do that, I just want to show you what happens if something failed. So now you got the great tick, perfect, but what if something failed? I'll just change something in the test. So for example, I delete one of the y here, which will make the test fail, right? Because it should be ty rather than tyt, right? So it will fail. I'll just show you how it looks like. I'll open that here and then git add --all, git, just git status to check, git commit. Demo fail the pipeline. All right, I'm going to git push now. Refresh it here. Running, great, still running on this script. Running on this commit, sorry. So it's still running. Oh, you can see that job failed. And similarly, it will show you what failed. So failed on this still with no walls. And it will give you more details information on what failed. All right, so it automates the process. And what it looks on your project, you will see this right icon here rather than the green tick. It's saying no. It's a visual sign showing that your file did not pass the test. Right. So you can go to, for example, this is our test project. And on the left-hand side, there's a build here. You can click on the jobs here where you can find all the jobs that was triggered. So we pushed it 3 times, and all of them triggered pipeline. 2 of them passed, the third one failed. It also shows you which branch is this in, which commit did we run the test on, and who triggered this pipeline. All right, you can navigate through, you can have a look here. So it's very similar here. GitLab also provides you a pipeline editor here. So other than editing the YAML file on your Visual VS Studio, on your local text editor, you can also edit the YAML file on GitLab. So it is very helpful because for YAML file, it has a very strict requirement for the indentation, like the syntax. So for example, you can see here, the pipeline syntax is correct. However, if you change it a little bit, for example, I add more spaces here, for example, like that, it's still okay. But if I do something like that, oh, it's still okay. But what if I have something like check? It will say that this GitLab CI configuration is invalid. So there's some syntax error. So this pipeline editor will check the syntax for your YAML file. So YAML file is very strict with this indentation. So the space at the beginning of each line, they are very strict with that. So if you are not using, for example, this editor, you can also search online for some like YAML file syntax check, so or YAML editors online. So they will also do this check for you. Oh, okay. Cool. So now I will answer the question here. Like the original idea was we want to do the test whenever we are making a merge request. Like how can we do that? So we can add a condition here. So we can say only main, and then merge. Is it called merge request? Is it called that? I couldn't remember whether it's like that or that. I'll just double check. Yeah, I was playing with it before the lecture. Not here. Where is it? Was on the slides. Where is it? Yeah, it's not here. All right, I'll just try and see. So the idea here, so what I'm doing here is I want to trigger this pipeline only when we are trying to merge to main and when we are only want to have a merge request. So we give it a condition, right? So let's try it. I can't remember whether this is correct, but I will double check. So we are going to do this again, and git commit -m add only before I do that actually, it's okay, we can do it. I'll do it first and I'll show you more examples. Add conditions to pipeline, and then let's git push. Let's go back to our remote repo. This is the test project. It's running, great. It's still running. Let's have a look. I hope it is correct. All right, so it's running properly, but the test still failed because we haven't, so the test was wrong, right? Great, but it doesn't show you. So just check out to another branch and I'll show you the merge request, like how it looks like, okay? So check out to another branch. So git checkout, that should be a branch like feature branch. And then now we have switched it to a new branch. I want to make some changes to it. I'll just change it back to the correct version, which should be ty here. And then git status to double check. All right, so we are on feature branch, and this is the changes that we made here. Git add -r, and then git commit -m demo merge with pipeline. All right, so let's git push now. So it will be an error message because we haven't set up the upstream for this feature branch. I just copy and paste here. Great, so let's go back to our remote repo, have a look at this test project. You see, I will just do the normal process when we merge requests. I'll click on the button here, and then I'm not assigning anyone here because Rennie is not here, but normally we need to assign a review. I'll just do myself, or assign to myself. Okay, and then create this merge request. And then you will see, it's not doing the thing. Normally, the reason that I'm saying it's not doing the thing was because there should be another column saying that it's running the pipeline on this commit because we are creating a merge request to main. I'm assuming that my syntax here is not correct. So I'm just doing a quick check. Is it here? Do I have a node here? No, I don't have a node here. Sorry, give me 1 second. It's not here. Oh, it's this one. It should be like that. Okay, I'll correct that one on my feature branch so I can demo like how we can trigger the pipeline with merge request. Okay, I'll do that. Git status to check. And then I'm going to git add -r and then git commit. I'm going to give a commit message. I'll say fix the pipeline with correct syntax. And then I'm going to git push. Let me check the remote repo here. You can see it's running. Here, I'll just go in demo. All right, so you can see that before you approve it, you can see there's a column called, like, they are actually running the pipeline. They are running the pipeline here on this merge request. So before you click on approve, double check they got a green tick. So if they get a red tick, you need to leave a message saying that your pipeline failed. I cannot approve your merge request. So when you're approving other people's merge requests, you do not need to manually run their test. Does that make sense? So now it's successful, then I can approve, and then I can merge. And when you're merging, they will run the pipeline again. because you are merging it to the main. So they are running the pipeline on the current main. So after merge, they are running the new main branch. Question?
Yeah, can I ask you, this pipeline is different from the local machine that you're running on. So how do you keep your test consistent with the pipeline test?
Oh, that's a very good question. So the question is, actually the machine that is running this pipeline is not our own machine. Does that make sense? So you will notice because the pipeline will only be triggered when we are pushing to the remote machine. So GitLab is running the test for us. So behind the scene of pipelines, there are actually some server machines that are running the test for us. So that is pipeline. So pipeline is just it's running on a server machine. So sometimes you will notice that your pipeline is very slow. That is because a lot of people are using that server to run their pipeline. So this happens very often when we are close to the iteration due, like iteration 2 or iteration 3 due. Like on that day, the server is super busy, so the pipeline will be slower. Somehow it will just refuse to work. So yeah, so that's a very good point. It's on another machine. So the question was, how does that machine know our test? The machine doesn't know our test if we don't give them our test. So when we push our project to the remote repo, so we are pushing everything to the remote repo, including the test. So what that server machine does is it will find our test in our repo. So for GitLab remote repo, so all those files are sitting on a GitLab server machine. That includes our function files and our test files. So when we trigger the pipeline, when we trigger the auto test, what they are actually doing is, I'll show you here. So these are the scripts that are triggered. So the first script is npm run test. Remember that when we have npm run test, it will find all the .test.js files in our repo, and it will run all the tests. So yeah, so this is also another tip. When you find the server which runs the pipeline is very busy, you can also actually manually run on your own computer, like npm run test, which is actually doing the same thing. Yeah, just the test is not run on your own computer, but run another machine. But how this helps us with the process is it will be automatically triggered. So you do not need to manually run everything, especially when you are merging in the code to main. It also helps with more frequently making commits, because otherwise if you're doing things all manually, it will take longer than automate, so you may hesitant to do more commits and more tests. But if the process is automated, you may want, okay, I can do more. I can do commits, do push more frequently. And you can also find the bugs earlier, rather than while you are done a lot of things and then wow, everything's wrong and then I need to start again. So you can commit more frequently and realize there's something not going properly early, so you can fix the bugs earlier. Especially when you are working on a pretty large project and everyone's committing. Yeah. So it helps with the scale problem in software engineering. Any other question? All good? Yeah. So it's clear why we need the pipeline. Okay, cool. Now let's have a little bit more closer look at this YAML file. Okay, so now we have the script here. We have the conditions here. What we can also have is we can have multiple tests here. So now we only have one stage, and in this stage we only have one test, which is called sanity test. So we can rename it as test 1. So it's just a naming. I can also add another test, for example, test 2, and then I will, yeah, I'll just keep that. And I can say on this test, I only do npm run test without, so only one script here, and then only one script here. So we can have multiple groups of tests. It's like when we write the JS test, we can have describe, and under that layer just some tests. Like how we group that is based on our design. For this pipeline, we can do something similar. So we can have two tests. We can test different things. For now, we are just learning npm run tests like the JS test, but in the future, we'll learn other tests. So that will be helpful in the later stages. And now we have two tests here. The second one just equal hello. And both of them are on this stage, which is called checks. Okay, let's see what will happen. So I'm going to git status to check first. Okay, we are on this feature branch, just one file that is modified, and then we'll git add --all, git commit, and then I'll say demo multi-tests. Okay, and then I'll git push, put in my password, and then go back to the remote repo. I'm going to refresh that, create a merge request. A review I'll do myself again, and then create merge request. And then you'll see that there are two tests here. So originally we only have one test on this check stage. Now we have multiple tests. And those two tests run in parallel. So there's no sequential order. It doesn't say, well, test one is successful, then I can move on to test two. It's not like that. They are run in parallel. But what if I have two scripts that I want to have a sequential order? I want to say, like, only if test one passed, then I want to do test two. How can we do that? I'll show you how. The way that we do that is by adding more stages. So we can say stage one, and then stage two, and then you put test one at stage one, and then test two at stage two. All right, I'll also make the test fail so you can see what happens. All right, so let's go back. Just git status to double check. I made edit to those two files. Git add --all, git commit. I'll say demo multi stages, and then git push. My passkey. Great. Go back to the remote repo. Did I push? Or what happened? Just git status to check. Yeah, what's going on here? Weird. Yeah, but anyway, you can find this pipelines running here, and then let's click on that. You can see now we have two stages. Test one failed because we made it fail, right? It's at stage one, it failed, so the test two was not triggered. So when you want to have a dependencies like between multiple tests, like you want to only this is successful, then run that one, so you can have multiple stages like stage one, stage two. Right, so now I'm going to show you what happens if this one is successful. So going to edit that one back, and then git status to check, git add --all, git commit. Sorry, a lot of boring, repetitive work. Demo passed pipeline, and then git push. All right, let's have a look. Why is it auto-merged? Did I do something wrong? But anyway, let's have a look at this pipeline. Oh, you can see that when test 1 is successful, it passed, and then test 2 and test 3 will also be triggered. So this is like sequential order. So when you want to have a sequential order for multiple tests, you can put it in multiple stages. All right. Do you have any questions so far? I have a question. Remember that what we said that the pipeline, like the test, is running on another machine. When something is running on another machine, what happens if they don't have our dependencies? Like, how can they run the test successfully if they don't have the dependencies? Right? Yeah. Yes, we need to install the dependencies first. So the reason that those ones was successful was because in GitLab, so we use the environment like for COMP1531, so it has our dependencies, so no problem at all. But when you have your own dependencies, you need to make sure that you install those dependencies on that server who's running this pipeline. Otherwise, they don't have the dependencies, they can't run our tests for us. How can we do that? You can just add one more thing to the script by saying npm install. And then they will find all the dependencies in our package.json file and run this script npm install first before run this npm run test. So we are making sure that the remote server who is running the pipeline has the same dependencies as what we have here in this project. Is that clear? Cool. So I'm going back to our slides. Where are we at the moment? Yeah, we have already demoed all of those. Yeah, so this is the runner. So this is called runner. So the one that runs our pipeline is called runner. So it's like a machine that runs the pipeline. So for GitLab and many Git platforms, we need to pay to use this runner. But CIC has already paid for us. So as long as you are practicing under the URL like COMP1531, then dash, then something, so under COMP1531, and then you can use this runner because CIC already paid for 1531. But if you are practicing on your own personal repo on GitLab, they will say there's no runner available because otherwise you need to pay for it, but CIC already paid for that. So you can practice on the lab. I remember it's level 4 or level 5, I can't remember. I think it's level 4, that you will have the pipeline, so you can practice on the lab. Or you can have your personal project, but you need to make sure that it is under COMP1531. And this pipeline is not required for iteration 1, so you do not need to use that for iteration 1, but for iteration 2, you will need to use that. But we are introducing this a little bit early because you need to practice on the lab first, and then you can implement that in the major project. So you are prepared for the next iteration, but no rush. You have some time. Yeah, so Rana is just another computer, and its job to run those pipelines. Yeah, they have an array of Rana. Yeah, so those commercial products like GitHub, Bitbucket, but you need to pay for that. But normally they have some free usage limit, but then they will start charging. Yeah, okay, so cool. So we have already talked about that. This is very important. So an important rule to follow is that your master branch should always be green. Like we mentioned that master or main should be the stable branch that the users are using. So you need to make sure that branch always get this green tick. So if your feature branch got that right icon showing that they didn't pass the test, do not merge that into main. You need to always make sure that your main branch has that green tick. So this is very important. Yeah, we also have some further reading. Yeah, so GitLab have provided a lot of instructions on continuous integration. Not this one. GitLab. Continuous integration GitLab. Yeah, the same one. Okay, they updated their website. So you can find more details about continuous integration or CI or pipelines. They are basically similar things here. So you can find more documentations there on GitLab. You can also find resources from Atlassian again. So they also have good resources. I'll just quickly show you so you can have a look after the lecture. Yeah, so how to set it up, how to use it, and what it actually means. So now we are just doing unit tests, but in the later you may want to have more tests like integration tests, unit tests, acceptance tests, etc., etc. And you can include all of those in your pipeline as different tests or on different stages. Cool, amazing. So this is about the pipeline. Oh, great, we still have a little bit time. Perfect. I'll just, any question about the pipeline? All good? All good? All good. So, yeah, static verification. We got very good question in our lecture last week about like what's the differences between static verification and dynamic verification. So what you have been doing so far in your part 2 project is dynamic verification because you are comparing the expected output with the actual function's output. So you are testing the behavior of the function or the behavior of the software. So that is called dynamic verification. It means that you need to run the script, you need to run the functions or run your software so you can know the behavior of the software, right? So that is called dynamic verification. But we also mentioned that there's another type of verification that you do not need to run the script. But there are some bugs, like potential bugs, that you can identify already. That would be great, right? So that would save a lot of time, a lot of like server or memory or resources, everything. That would be fantastic. So that is called static verification. The examples, I'll use this example again. I think this is a very good example. Yeah, this is the one. Not that one. Many strings. Yep, okay, cool. So this is the example that we used multiple times in this course already. This is a very good example. So this is a function which is called many strings. And what we wanted to do is we want to repeat this string for repeat number of times. And then we are console logging it. So let's just have a try. Yeah, here's the one. I'll just clear it. How to run this file. How to run it? Node, many, string, root.js. Uh-oh, what's happening here? It's not console logging the strings. Why? Why is that? Any hints? Any findings? Any ideas? This is so bad. Like when we are writing a function, we got nothing, so we don't know what is wrong here.
Because your parameters like split.
Yes, that's correct. Did you find that as well? What was wrong here? Any? Raise your hand if you found what was wrong. What about the others? Have a look. Oh, yeah, cool. 5 more seconds. 5, 4, 3, 1, or 2, 1, 0. Okay. Yes, the error here is we are having the wrong order here when we call this many strings. It should start from repeat and then string. However, when we call this many string, we start with the string and then the 5, like the repeat numbers. Like how should we deal with like cases like that? What should we do? There's no error message print out. Like this is so bad. What should we do? Any solutions here? Just using what you have learned so far. Like, how should we deal with it? What did you have an idea? Like, all we want is an error message, right? So all we want is just an error message. It's the worst case scenario that we are doing something wrong, but we are not getting any error message here. That's the worst case. So all we want is an error message. Well, you may think, I can solve this problem. I can do something like that. So very similar as what we are doing in iteration 1, part 2. Right? We are writing those errors here. So we can say, well, if repeat is not a number, then we will console log an error saying that repeat argument is not a number. Right? And then if string is not like a string tab, and then we console log another error message. It's like what we are doing now in part 2. And if all those checks passed, and then we do the actual thing, like the main body of the function. So let's run this again and see what happens. Runtime. Great. So we got the error message. But I think I did something wrong here. What was wrong here? All right, I think there's something wrong with my script. But anyway, so what we wanted was the error message. So what we wanted is like there's some error message telling us, well, you are doing the wrong thing. The tab is not assigned properly, right? So a lot of people may, when we are all using JavaScript, a lot of people may realize, well, it's great that JavaScript can have like dynamic tab. You do not need to declare the tab or define the tab when you declare a new variable, which is great, it's flexible. But it also brings us some trouble because it's flexibility. Because they won't give us the error message because they just ignore it. So then, yeah. So tab safety is actually very important for us to identify mistakes like in the many string example. So in C, you never encounter such kind of problem because when you are using C, you need to define its tab. Right? If you are like assigning the data tab wrong, you will get an error message. But in JavaScript, we don't get that error message. So JavaScript on its own is not tab safe. So it's not safe when we are using JavaScript. How can we do that? One solution is like what we were doing here. So we can catch those tab errors during runtime by writing some if scripts. So we can catch those errors during runtime. So we are checking the tab during the runtime. This is possible, yeah. But what we can also do is by checking the tab before runtime, like how C does. So this is where we introduce tab script. Have you heard of tab script? Anyone has heard of tab script? No? Yes? No? Majority is no. Yeah, cool. So by definition, we say tab script is a language built on top of JavaScript. But no panic, no panic, no panic. We are not learning a brand new programming language. That would be too much. So tab script is just something that built on top of JavaScript. It's like when we learn Jest, we are still writing JavaScript, right? But when we install Jest, there's some like framework we can use. Like there's the describe, there's the expect to be, to equal something. But TypeScript is very similar. You can think of it like another package that we are installing on top of JavaScript. And what it does is it helps us to check the tabs. That's it. So no panic, no panic, no panic. So it's not a completely new programming language. You can just think of it like another package. Although we say TypeScript is a programming language, but it's not a standalone programming language. So its job is just to check the tabs in your program and output that JavaScript, and then output JavaScript that is then run with Node. Let's have a look at this example. So this is an example of TypeScript code. So you can see that the only difference is we are declaring its type. So we are saying this parameter A is a number. This parameter B is a number as well. So that's the only difference. Okay, so let's have a look. Where we are, my code.ts. Okay, so just clear it here. How do we run it? Oh, that's a good question. How do we run it? Do we still use Node? Unfortunately, we can't, because Node is the one that runs JavaScript code. So as we mentioned, that TypeScript is like another package that we install for JavaScript. So we need to first install that TypeScript package so that we can use it. It's like when we want to use Jest, we need to make sure that we have installed Jest. So similarly here, like how do we install TypeScript? We also provide you this one here on the slides. So all you need to do is to npm install, go back here, install it. Okay, installing, great. Let's give them a few seconds. And then just imagine, like think about it. What do you think we should run it? Like remember how we ran Jest? Before we added the script to package.json file, what we did was we looked at the .bin file under the node modules. Right? So this is what we did when we ran Jest. So similarly, we used the same method to run TypeScript. I've already put it in the slide, so we can just copy and paste. So this is something under the node modules. Here. And then the way we run it is by, remember that when we first ran Jest file, it was like that. Remember that before we add the Jest to the package.json file. So similarly, we do it like this, and then followed by the file name, which is my code.ts. Oh, this is one difference as well. So for JavaScript code, its file ends with .js. For TypeScript, it ends with .ts. Okay, so let's try to run it. Yep, it console logged the array because we want to get a sum of 1 and 2. So this is how we can run TypeScript code. Yeah, okay. So you may ask, like, what are the types that we can use for TypeScript? So the most commonly used types are this array, number, string, boolean. So those are the most commonly used. It's less complicated than C. Like C, you have a lot of different things. But for TypeScript, the most commonly used ones are just those array. Okay, let me have a check the questions online. From Angela online asking, could we assume that the parameters passed will be the right types for iteration 1.2? I don't think we can make this assumption because you need to implement it correctly. So for example, if in, oh, did you mean the error cases? Oh yeah, for iteration 1, you do not need to have those. You do not need to have those error cases about like the tabs. You don't need to do the tab check during iteration 1.2. Yeah, we'll talk more about tabs in iteration 2. So you do not need to worry about that for your iteration 1. Any questions so far about how to run TypeScript and what is TypeScript? All good? Yeah. So again, we'll use TypeScript starting from iteration 2 as well. You do not need to worry too much about that for your iteration 1. Okay, that's the new concepts that I want to introduce today. So we'll talk more about TypeScript in our next lecture, but I don't want to overwhelm you too much today. So that's all new concept. Any question before we wrap up the lecture? Yeah, question.
Do we need to check for the type safety in our 1.2 test?
Yeah, that's the same question as Angela. No, the answer is no. You don't need to worry about type safety for iteration 1. We will care about that from iteration 2. No, good. Any other question? Oh, good, no question. Okay, amazing. Thank you so much. That's all for today. Thank you.